Hi everyone, I'm Or Madar from Reichman University. Today, I'm excited to present Tile Diffusion, a novel approach for generating seamlessly tileable images using diffusion models. We invite you to visit our paper webpage to view our full paper, supplementary materials, code, and additional results. Let me start by defining what we mean by tiling. Tiling is the seamless connection of images to create coherent visual fields. The key requirements are that images connect without visible seams, preserve visual continuity, and can be repeated infinitely while maintaining logical structure. As you can see in this comparison, non-tiled images create obvious discontinuities, while properly tiled images flow seamlessly. Image tiling is crucial across multiple domains. In video game design, it's essential for creating environments and repeating assets. In texture creation, it forms the foundation for 3D modeling with realistic materials like brick walls and wood floors. And in digital art, it enables infinite pattern generation for wallpapers and web backgrounds. We identify three main tiling scenarios. Self-tiling, where a single image connects to itself. One-to-one tiling, where two images connect at specific edges. And many-to-many tiling, where multiple images connect in complex patterns. This last scenario is particularly challenging and hasn't been well addressed by existing methods. Looking at existing work, most methods focused on specific scenarios. For self-tiling, we have approaches like ControlNet and asymmetric tiling. For one-to-one scenarios, there is seamless tiling painting, but very few methods support the complex many-to-many scenarios. This table summarizes the landscape. As you can see, our method is unique in supporting all three tiling scenarios across general image domains, not just textures. Most existing approaches are limited to self-tiling or specific texture generation tasks. Our solution, Tile Diffusion, works directly in latent space during generation. We introduce two key constraints, a tiling constraint that creates seamless transitions and a similarity constraint that eliminates artifacts in complex arrangements. Importantly, our method supports all tiling scenarios for any domain in image synthesis and also works for image-to-image tasks. What makes our approach special is that all images are generated together in latent space, allowing tiling information to flow between images during creation. This enables semantic understanding across boundaries and ensures output images have tiling properties inherently, unlike other methods that typically enforce tiling as a post-processing step. Let's look at our evaluation results. For self-tiling, we compare against seamless tiling painting and asymmetric tiling. In landscape examples, our method and asymmetric tiling maintain logical continuity, while seamless tiling painting shows misalignments and artifacts. For textures, all methods perform well due to the lack of complex high-level structure. For one-to-one tiling, we compare against seamless tiling painting. Our method demonstrates superior coherence and seamless transitions. Despite STI using a relatively large connection region, it still shows noticeable discontinuities and struggles to maintain consistent content across tile borders. Here's where our method really shines. Many-to-many tiling scenarios that no other method can handle. We can create complex patterns like this 3x3 brick arrangement, horizontal watercolor forest paintings, and vertical step sequences. This capability is entirely unique to our approach. Our applications span multiple domains. For texture synthesis, we generate diverse, seamlessly tileable textures directly from text prompts. Each of these examples tiles perfectly in a 2x2 arrangement covering materials from wood and stone to fabric and geometric patterns. For 360-degree synthesis, we create wraparound panoramic images with seamlessly connected edges. This produces continuous views perfect for wide-angle landscapes or architectural panoramas. We can also make existing non-tileable images seamlessly tileable while preserving most of the original content. This is particularly valuable for artists and designers working with existing assets. We even demonstrated remastering pixel art, transforming low-resolution game assets into high-quality tileable textures. Our method generalizes across different diffusion architectures. We've successfully tested it with Stable Diffusion 3, Stable Diffusion XL, and even ControlNet, showing the broad applicability of our approach. To summarize, tile diffusion enables complex tiling scenarios that were previously impossible, works across all image domains, and integrates seamlessly with existing diffusion models. The code and additional results are available on our project webpage. Thank you for watching.